All right, everyone. Let's go ahead and take a look at something called the square root property. So the square root property is important in that it helps us to solve a quadratic equation. So the square root property is as such. It says that if x squared is equal to, let's say, k, then we can also say that x is equal to the square root of k, or x is equal to the negative square root of k. We could also rewrite that as x is equal to plus or minus, right? The positive root of k, the square root of k, and the negative root of the square root of k. So in essence, we're taking the square root of both sides when we start back up at the beginning. And when you square a square root, so that left side, that'll just leave the x. And on the right side, we'll use plus or minus because with all square roots, there's a positive and a negative root, right? For instance, if you take the square root of 16, the answer is not only 4, but it's also negative 4, right? A negative 4 times itself makes positive 16, and a positive 4 times itself makes positive 16. So that's why we have to use the plus minus. All right, let's go ahead and work through some examples. So our first example says x squared equals 7. So to apply the square root property, remember the property showed that you have to have some variable on the other side that's squared, and then some value on the other side. I'll just put the number sign there. And then this x can be some quantity, right? There could be some stuff going on within the parentheses too. So we'll see problems like that later. But this looks like it's square root property form ready. So we just go ahead and I'll show that step where we apply the square root to both sides. So then when you square a square root, as I was saying, they kind of like cancel each other out. They're inverses of each other. So you're left with x equals plus or minus the square root of 17. Here you want to try to break down the square root of 17, but to me, it looks as though it's a prime number, right? There's no perfect square root that goes into 17, so you're done with that problem. Looking at another problem, let's try x squared equals negative 25. All right, so this looks to be in square root property form ready, right? So there's something squared on one side and the value on the other side. So if we take the square root of both sides, and I'm not going to show it anymore for this left-hand side, as I've already shown it right there in the previous problem. That's what you're going to do to that left side. But I won't be showing it, so I'll just jump right to it being x is equal to plus or minus the square root of negative 25. All right, so this throws a little monkey wrench into things in that we have the negative sign underneath the radical. If you think about it, what number times itself would make negative 25? Well, I don't think there is none, right? Positive 5 times itself is positive 25. A negative 5 times itself is still a positive 25. So there's no number times itself to make a negative 25. So in depending on the part of the course you're in your algebra course, your instructor may say, okay, this cannot be completed. It's not a real number. Or if you're further along, they'll introduce I for imaginary number, right? So we'll go with the second portion, and maybe your instructor has included that. So our answer will be x equals plus or minus, and because of that, negative. So I is equal to the square root of negative 1, actually. Because of that negative sign, we use I, and then we can write 25 by itself. And now we can actually take the square root of 25, which is 5, and put it right next to the I. So x is equal to plus or minus 5i. All right, and then in the third example, let's take a look at this one, a little bit more challenging. X minus 4 squared is equal to 12. All right, let's give that a try, give it some space. So it looks like to be in square root property form. Remember earlier I was saying square root property form looks like this. However, you could have some quantity on the left, and to me that's what that looks like. It still looks like square root property form, but we have a quantity in parentheses, the x minus 4. So no worries, you still take the square root of both sides. And I said I wasn't going to show it, but I just will go ahead and show that again, how we're squaring square root, and they kind of cancel because they're inverses, and you're left with x minus 4 equals plus or minus. And now with the 12, you have to think back to what you studied in class as far as simplifying, right? So simplifying radicals. So the largest perfect square root that goes into 12 would be 4, and it goes 3 times, right? We're looking at all of these perfect square roots, just to refresh your memory. All of these perfect square roots, 4, 9, 16, 25, and so on. The largest one that goes into 12 evenly is 4. 9 goes into 12, but not evenly, so we used 4. So 4, and it goes 3 times. So x minus 4 equals plus or minus, the square root of 4 is 2, so that comes on the outside, and the 3 stays under. Now again, it's an algebra problem. You're solving for x. So we have to get the x by itself. So we do the opposite of that negative 4, and we say x equals 4 plus or minus 2 square root of 3. All right, and then that will be our final answer. X equals 4 plus or minus 2 times the square root of 3. All right, so this was solving quadratic equations using the square root property.